Hello everyone, welcome to Sweetie Speaks official YouTube channel. Today we are at day 85 of 111 days verification challenge. The skill set which we are focusing on right now is system Verilog, and we are solving the practical problems now like designing and verifying the actual designs. If you have seen in the previous days challenge, we have seen FSM design and verification, we have seen memory design and verification. Another important kind of thing which we always have in our SOCs is counters. Today we are going to see verification of an up-down counter. For that, first let me take you through the design of up-down counter. If you see here, this is the design of my up-down counter. The name of module is counter. This counter module has three different inputs. The first input is clock, which is the clock signal, which will clock your design. Then I have the enable signal, which will enable your chip. Then I have a load signal for loading your data. And I have a up down signal, which will tell whether your counter is up or down. I have a 4-bit input data and I have a 4-bit output queue. One very important thing to note here is that your design is at the rate negage of clock. Usually you will see posage of clock, but in my case I have negage of clock. Please take a note of this. And another thing is, now when your chip is enabled, when enable signal is high, then at that time if the load is present, then my data will be loaded to output. You can see the data value is coming to Q, which is your output. If your load is not there, here if you see in if, I have else if you have up down. Okay. Now when your up down counter value is 1, what does it mean? It means that it is an up counter. When up down value is 1, it is an up counter. That is why your output, if you see Q, I am incrementing to value 1. Otherwise, if your up down is not 1, then it means it's 0. And that time I'm decrementing the output Q. And then at the negage of clock, I'm displaying the value of Q. Understood the design? Okay. You need to properly understand what are the inputs and how at the trigger condition like this enable is a trigger. First of all, negage of clock, then enable, then what happens when load is there, what happens when up down is there. Understand it properly. Now I will tell you what you need to do to verify this design. This is the challenge. I have showed you design. Now this is what you need to do to verify. First, you need to create a testbench file named testbench.sv to verify the design and analyze the waveform. This will be the testbench file, testbench.sv. Now, what will your testbench contain? First, at time equal to 0, make your load equal to 0, data equal to 0, your up down equal to 1 and your enable equal to 1. This you will do at time equal to 0. After 3 clock cycles, you need to drive your data to a value 5. After that, again 2 clock cycles, you make your enable equal to 0. After that, again after 1 clock cycle, drive your data to Z. I have told to drive your data to Z. Again wait for 4 clock cycle, drive bit 3 of data to 0. Only bit 3 of data, drive it to 0. And again after 4 clock cycles, drive your data back to the initial value 5. Create the stimulus, analyze the output, see if the design is behaving as expected. As we are moving towards the challenge, I am trying to give you little bit more challenging things here. If you see, I am telling you to drive data to Z. I'm only telling you to change the bit 3, because slowly, gradually, we really want to improve the complexity so that we are ready to verify complex design. So I kindly request you to please drive the stimulus, analyze the output, analyze properly when each and every input changes, like when each and every enable has some change, up down has some change, load has some change, data has some change. Please see what happens to the output and then see if it really behaves as your design is expecting. If not, then there is some problem, then there is some bug in your design. Please solve this challenge today, and tomorrow I am going to see you with a new challenge in day 86 challenge. Thank you and best luck.